Hey guys, hope everyone had a really good Easter and got to eat your turkey and filled up, even if I didn't get to spend it with family. Still good. Made my own turkey for the first time, so that was kind of exciting. Didn't mess it up too bad. Everyone here was good, so we're gonna move forward, I guess, for the next foreseeable future. I know it's not a lot of people watch the first video. Hopefully, that's because it's a review or you're just good with the notes, whatever. I'm going to keep putting them up, and hopefully, if you need them, you'll look at them. We're going to move into chapter 5, which is really small. There's a lot of extra kind of lab and those kind of research assignments that we don't really have a lot of time for with all the days we've missed. So we're just going to cut it to 2 short videos. I'm going to do them both, post them both at the same time. So 5.1 is the combustion of hydrocarbons. Chapter 5 title is chemical processes. Hydrocarbons, first of all, if you don't know what a hydrocarbon is, a hydrocarbon is an organic compound, number one, which means it's naturally occurring in the earth and or made from naturally occurring parts to it. So those are our organics, and they all contain, all of our organic compounds contain at least one carbon-carbon bond, and a lot of times, especially in the case of hydrocarbons, a carbon-hydrogen bond. Hydrocarbons are made up of only 2 things, carbon and hydrogen in various amounts. So carbon backbone, and then hydrogen's attached to those carbons in a molecule. So when we talk about combustion, we're actually talking about the process of burning something in the presence of oxygen, right? We know that oxygen's in our air, so when we burn things in the air, just outside in a fire, our wood always gets burned up first because we have an abundance of oxygen. There's tons of oxygen in the air. So all the wood gets used up. So all the fuel is used in that particular reaction. And that's called complete combustion. So when we get complete combustion, what we have is if all the fuel is used up, then all we produce is carbon dioxide and water. That's complete combustion. In other times when we have a fuel-rich environment, so we have more fuel than, say, oxygen available. So, instance where you're doing things in a closed space and there's only so much oxygen available, and we're burning things. Oftentimes, what happens is we have fuel left over at the end, and we get what we call incomplete combustion. And incomplete combustion is very similar. You still get carbon dioxide and you still get water as a product. The difference is with incomplete combustion is that you get byproducts that we really a lot of times don't want. One of them is, as a possibility, is carbon monoxide, which we know is extremely toxic to human cells. So this is why when you start an engine in a garage, the carbon monoxide is always produced. There's always incomplete combustion. There's more incomplete combustion in a car when we are burning gasoline. So when we're on a highway, we burn gasoline very efficiently because your car is going the same speed the whole time. So you put it on cruise control, it burns very efficiently, and therefore we get mostly complete combustion. But we do get it's still a little bit incomplete. You get some byproducts. When you're on the city streets and you're stopping and you're starting and speeding up and slowing down over and over and over again, that's less efficient and it's more incomplete, and therefore you get more carbon dioxide produced. So if you let your car idle in a garage, lots of carbon monoxide being produced, and if it's in a closed space, it fills pretty quickly, and then if we breathe it, it's toxic and you can end up dying in that particular scenario. So the other thing that we produce is soot. And soot, those of you that have a wood burning stove or a wood burning fireplace in your house, you know what soot is. It's essentially like a solid carbon kind of dusty particle, but it's very dirty. That's the stuff when we have smokestacks in our society at factories and incomplete combustion is taking place and the smoke rises out of the stacks. If it's incomplete and there's soot in there, it's that black stuff that gets absorbed into the clouds and then rain, and so we get some of those byproducts that we don't want, incomplete combustion, as opposed to complete combustion. So that's really all 5.1 is the difference between complete and incomplete combustions. They give a couple of concerns with incomplete combustion. We don't get all the energy released. We know that everything is made up of bonds, and when you break all the bonds down, that you release as much energy as possible. So if we don't get incomplete combustion, we don't release all the energy that we could, and that's inefficient, which we try and avoid. The other one is that both carbon monoxide and soot are inhalation hazards for human beings. So if we're inhaling a lot of that, either one of those, that's toxic for our cells, and worst case scenario can cause death of cells and possibly death of that particular organism. So we try and avoid that as well, obviously. But pretty straightforward with those two, complete and incomplete, knowing what an organic compound, a hydrocarbon is. Okay, so I'm going to stop this one, make it short, and then quickly do 5.3 as well. Okay, see you in a few minutes.